Okay, finally, example 4 basically says prove or disprove the following. So some of these equalities are true, some of them are false, and you want to be basically a pessimist or an optimist and prove or disprove each one of those. Now, if it helps if you're a little bit familiar with theorem 6.2.2, for example, if you are familiar with it, you will recognize that this does not equal to that. It almost is right. The only thing that's not right is that union should be an intersection, because that would be then De Morgan's law. So it seems like this first one is going to be false, and so what I'm going to be doing is a proof by counterexample. Okay, so I'm going to disprove it by doing a counterexample. So to do the proof, I'm going to build a small Venn diagram, and I'm going to say let A, B be the following sets. So let A and B be the following sets. And so in my little Venn diagram, the red circle is going to represent A. I'm going to write 1, 2 in it. And then the 2 is going to be again shared by A and B. So B is going to be 2 and 3. So the set A is the red one, the set B is the blue one, and 2 is being shared. And I'm going to put a 4 on the outside in the universe just in case. Okay. So next, what I'm going to do is research the left-hand side. So what is the left-hand side equal to? So it's equal to A union B, and then the complement of that. So I'm going to do A union B by itself first, and I'm going to do A union B complement and investigate. So what is the A union B? The A union B is going to be 1, 2, and 3. It's all the elements of A and all the elements of B together in one place. Now the complement of that is everything that's in the universe that's not already 1, 2, 3. And the number there would be 4. So for now, I want you to keep 4 in your mind. And let's go ahead and check the right-hand side. So what is the right-hand side equal to? Okay, the right-hand side consists of A complement and B complement, and then the union of A complement and B complement. Okay, so let's start with A complement. A complement is everything in the universe that's not already inside of A. So in other terms, those are the numbers 3 and 4. B complement is everything that's not already inside of B, and that is 1, 4. And finally, we want the union of those two sets. The union is going to be 1, 3, and 4. And again, I want you to kind of just keep that in mind. And what I would like to do now is compare the left-hand side with the right-hand side. And as you can see, they're not the same, right? The 1, 3, 4 set is not the same as the 4 set. So note that the left-hand side is not equal to the right-hand side, so the statement is false. So A union B complement is not A complement union B complement. So that's the end of the problem, QED. Okay. Now, just a little heads up, this is not the only counterexample that works. I chose this counterexample because it reminds me of another one I did previously in the section, but really any random sets A, B should get the job done. This is just one particular example of that.